Hey everyone, and welcome to The Explainer. So, have you ever wondered what actually separates the people who merely try to learn a complex new skill from the ones who achieve literal Olympic-level mastery in it? Well, today we are going to synthesize two incredibly powerful yet totally distinct frameworks into a single master formula for achievement. First, we're going to look at the biological hardware of our brains using John Sweller's cognitive load theory. Then, we're going to pair that with the psychological software you need to sustain excellence, diving into Angela Duckworth's really groundbreaking concept of grit.
To give your brain a quick, clear roadmap of where we're headed, here is our agenda for today. 1. How human brains learn. 2. Managing cognitive load. 3. The power of grit. And 4. Developing gritty habits.
Okay, let's dive right into this because, we've all been there, right? You're staring at a massively complex math problem, or trying to learn a new language, or reading some dense technical manual, and suddenly, your brain just shuts down. It feels physically impossible to absorb even one more fact. So why does that happen? Well, to answer that, we really need to understand the fundamental biological hardware of the human brain.
Section 1. How human brains learn, focusing on cognitive load theory.
This brings us to the pioneering work of educational psychologist John Sweller. His research maps out this very specific three-step chronological process for how we actually acquire information. Step 1, your working memory processes the new data. Step 2, learning happens as your brain successfully transfers that data. And Step 3, your long-term memory stores it into these highly organized structures called schemas. Sounds simple enough, right? But there is a massive biological catch right there in Step 1.
And that catch is the number 7. Research shows the average person's working memory can uniquely hold only about 7 chunks of new information at a time. That perfectly explains why we can barely remember a grocery list without writing it down. Worse, we can only actively manipulate. Actually, scratch that. It's more like we can only actively juggle about 4 of those chunks simultaneously. This right here is the ultimate biological bottleneck of human potential. And this brilliantly illustrates that very delicate pathway information has to take. You can see how the new information literally funnels into that tiny restricted working memory. If we try to cram way too much in at once, boom, cognitive overload occurs. The pathway is entirely blocked and learning stops dead in its tracks before the info ever has a chance to reach your long-term memory schemas. So, let's contrast these two systems to really get the picture. Your working memory is extremely limited in capacity. It can only hold small amounts of new info for a very short, fleeting time. But your long-term memory? It's basically virtually limitless. It can organize vast amounts of stored info into incredibly complex schemas. Because there are no real limits when your brain is dealing with familiar information, the whole goal of any learning strategy absolutely must be safely and efficiently transporting data from that restricted working memory into your limitless long-term memory.
Section 2. Managing cognitive load. Let's look at optimizing that brain hardware.
Knowing we have this frustrating biological limitation, how do we actively optimize it? Well, this logical flowchart provides a really fascinating decision tree for exactly that. You first ask, how complex is this lesson? If it's highly complex, you absolutely must use strategies to manage and reduce the cognitive load. But notice the right side of the tree, this is wild. If the information is simple, you actually need to increase the complexity to challenge the learner and prevent boredom. Let's look at one of the absolute best ways to manage high complexity. Strategy 2 from our source material, which is using worked examples. Imagine trying to learn Newton's second law of motion for the first time. It's tough, right? By explicitly mapping out a worked example, showing exactly how an increase in net force directly doubles the acceleration when mass is held constant, a teacher prevents the student's working memory from overloading. The student doesn't have to burn energy guessing the pattern. They can dedicate 100% of their limited working memory to just understanding the underlying physics concept. So, if we pull the absolute most actionable strategies from all this educational research to help clear that cognitive pathway, we get these core rules. Tailor your learning to existing knowledge using a part-whole approach. Break things down into bite-sized subtasks. Ruthlessly cut out redundant, inessential information. Simplify complex data by presenting it both orally and visually. And finally, only increase independent problem-solving once proficiency is established. That is how you master the hardware. But what happens when the hardware is totally optimized and the task is still just relentlessly, brutally difficult?
That brings us to Section 3, the power of grit and sustaining excellence.
This shifts our narrative track to the software. Because, let's be honest, clearing cognitive load doesn't make the work easy. It just makes it mathematically possible.
To sustain the intense, grueling effort required for true excellence, we have to turn to Dr. Angela Duckworth's formal definition of grit. She defines it as the power of passion and perseverance to endure adversity. This is a massive paradigm shift. It completely moves our focus away from innate talent and places it squarely on behavioral endurance.
And the crucial point here is found in Duckworth's developmental formula of excellence. Notice the math. Talent multiplied by effort equals skill, but it doesn't stop there. That newly acquired skill multiplied by effort again equals achievement. That's right, effort literally counts twice in the mathematical equation of achievement. Talent just dictates how fast you might initially pick up a skill, but sustained, gritty effort is what actually refines mere skills into world-class abilities.
But you might be wondering, where does this magical ability to apply effort in the face of suffering actually come from? Well, Duckworth points to psychological research that reveals two fundamentally different responses to adversity. The first is learned helplessness. This is where you believe you simply cannot control your suffering, so you just learn to endure the pain. The exact opposite is learned optimism. This is where you resiliently seek solutions and push toward relief no matter what. Optimists embrace a growth mindset. They see failures as useful data, not as some permanent state of being.
Section 4. Developing gritty habits, specifically looking at the U.S. Air Force Academy approach. So now that we know what this psychological software looks like, how do we actually install it? Let's look at one of the most demanding environments in the entire world, the U.S. Air Force Academy. Cadets there build gritty habits from the outside in. By deliberately engaging in really challenging extracurriculars and following through despite massive obstacles, they internalize core values. And the research reveals a brilliant truth here. People who learn to do hard things become significantly better at doing other hard things. Grit isn't a trait, it's a muscle.
There's this incredibly powerful quote from Justin Stoddard's review that I think perfectly encapsulates our ultimate goal today. He says, "Learning to be at peace in the eye of the storm is something that requires perspective, patience, and insight." I mean, wow. It's really all about merging that optimized cognitive bandwidth, the hardware, with an incredibly resilient, optimistic psychology, the software.
Which leaves us with this final, provocative thought to take away today. I want you to take a hard look at your own life, your own studies, or the teams you lead. Are you building an environment that actively respects your cognitive hardware limits, using smart schemas and managed loads, while simultaneously and ruthlessly demanding gritty, deliberate practice from your psychological software? Because let me tell you, when you combine optimized learning pathways with relentless perseverance, there is quite literally no limit to what you can master. Thank you so much for exploring this with me today, and I challenge you, go put this master formula into practice right now.